Yes, student, next property is thermal stability of hydrides of 15th group. Thermal stability, that is, on heating, the stability of covalent bond present in a molecule. Like here, we can represent EH3. This is a simple hydride. Okay, so on heating, if we take its two molecule, okay, will convert into E2 plus 3H2. That is what there is breaking down of what EH bond takes place. So the breaking down of EH bond takes place will depend on breaking of EH bond. Okay, depends on two factors. Depends on two factors. Okay, which two factors? First one, strength of covalent bond. Strength of covalent bond. Second one, bond length. Bond length, that is what? EH bond length. We can say three factors. And the third one is bond dissociation enthalpy. Actually, these two, okay, are related to each other. Whenever we can classify it bond dissociation enthalpy. Bond dissociation enthalpy. Getting? Now, student, you know that bond length is inversely proportional to bond dissociation enthalpy. Getting? And bond dissociation enthalpy is directly proportional to stability. Stability. Getting? On moving down the group, moving down the group, what? EH bond length increases. EH bond length increases. Why it is increases? This is due to increase in size of E. I am writing E, that is what? Central element. Okay, hence bond dissociation enthalpy decreases. Getting? So thermal stability okay, also is in order. Okay, now in NH3 bond length is very short, so its thermal stability is very high. It is because bond length is shorter and the bond dissociation enthalpy is very high. But in case of PH3, the bond length is higher, so the bond dissociation enthalpy is lower. Okay, and so on. We can write for ASH3. Okay, also in NH3, that is what? Ammonia. Okay, strong intermolecular hydrogen bond is present. Intermolecular hydrogen bond is present. Okay, now being it is quite strong, therefore the breaking down of ammonia is quite difficult, therefore it is highest thermal stable. Student, thermal stability, on the basis of it, we can explain one more very important property. This property is known as what? Reducing nature. Okay, now the reducing nature or reducing strength. Okay, all hydrides act as a reducing agent. Now, what is the meaning of reducing agent? So, one which can liberate hydrogen, liberate hydrogen. Liberate means release hydrogen. Release hydrogen. That means what? If it will release hydrogen, then any other compound can gain this hydrogen, that is getting reduced. Means what? These hydrides act as reducing agent. Getting? That is, they are providing their hydrogen to other substances. Getting? Now, the release of hydrogen will again depends on the same factor. What? Bond length, bond dissociation enthalpy, and type of intermolecular attraction force. Isn't it? So student, you know that in the case of ammonia, there is strong intermolecular hydrogen bonding is present. Second one, the size of nitrogen is smaller. Therefore, the NH bond dissociation enthalpy is higher. So, if the NH bond dissociation enthalpy is higher, therefore ammonia is unable to easily liberate hydrogen. Thus, ammonia is weakest reducing agent. That is what? Here, now we can view the order of reducing agent or nature. So, what will be the order? You can say ammonia is the weakest reducing agent, okay, while BiH3 will be the strongest reducing agent. Why? Because it can very easily what? Liberate hydrogen. Are you getting? That is what? The thermal stability and the reducing strength are inversely proportional. Means NH3 is, okay, the weakest reducing agent, while the pH3 is more, then ASH3 is even more, then SbH3 is even more. Okay, now you can understand simply here, the thermal stability is inversely proportional to reducing strength.